Well, hello, everybody. How are y'all doing today? Welcome to the Java Champion Conference. And today, I would like to introduce to you Josh Long. The two things we have in common is we both work on Spring and we both have coffee. And we like Spring Boot. So, Josh, is there anything else you could think of right on top of those three?
I'm a big Glenn Renfro fan. And I assume you are as well. So that's a commonality there.
Yeah, but I'm a bigger Josh Long fan than the Glenn Renfro fan. I'm just going to say, just saying it, bringing it up.
Impossible. Impossible.
Well, sir, I'm going to turn the stage over to you. And folks, enjoy. I know I will. And Josh, the stage is yours.
All right. Can you all see my screen? Fingers crossed. Do you see my slides? Slides. I'm assuming you see my slides. Okay, whatever. Okay. My name is Josh Long. Welcome, everybody. Thanks so much for hanging out today. I know there's a lot of choices. I know there's a lot of things you could be doing right now, but you instead chose to hang out with me. I am honored, obviously, and grateful to be here. My name is Josh Long. I work on the Spring team. I'm a Kotlin Google developer expert and a Java champion, and I'm a YouTuber, which is it's an adventure. Yeah, you can find me on YouTube there, youtube.com/@coffeesoftware, wherein I do, moving pictures and stuff. It's fine. Nobody's ever died there, so that's good. I'm trying to set the bar real low here. That way you'll find something. I've got code for this talk. It's on github.com, Josh Long, Bootiful, Spring Boot 3. My email, should you have questions, comments, feedback, whatever, is josh@joshlong.com. I'm on Twitter, X, whatever. At Starbucks Man, you can find me there. And my friends, I'm here before you today because I don't think there's ever been a better time to be a Java and Spring developer. Truly an amazing, amazing time. And I really want to set that as the baseline here, right? There has never been a better time. I'm just so very pleased with all the things that we are able to do now. There are new opportunities, not just incremental upgrades, but whole new paradigms that have become possible thanks to the fast-paced innovation of both Spring and the JVM. It's a sort of synergistic evolution that has just resulted in just a force multiplier, stepping function of considerable more power and new paradigms and so on. A lot of buzzwords, synergies there. But just trust me, we're going to see a lot of this today. And of course, to do that, as always, we have to do what we always do, which is go to my second favorite place on the internet, start.spring.io. We're going to go here. Sorry, I'm just opening up this keyboard and just realized it's got some cruft in it. All right, so start.spring.io. We're going to build a new application, friends. We're going to use 3.22, but you know what? There's a little bug, a tiny bug in this, so I'm going to actually step back down to 3.2.1 as soon as I get the project opened. But we'll do that. I have a choice about what I want to name it for the group. I'm going to call it Bootiful, and I'm going to call this Service. And the reason we're going to call it Service is because I'm really good with names. I get that from my father. He too was great with names. When I was a small boy, we had a small white dog, and my father named him White Dog. And then this dog, he was with us for, I don't know, 10 years or so, and then he disappeared. I don't know what happened. Maybe he got a job. I don't know. But anyway, he went to somewhere else, and then magically, coincidentally, another small white dog appeared before our screen door, tapping, looking for a new home, and we adopted him, and my father named him 2. Now I'm not sure if that's because of it's like the number 2, or if it's because of like TOO, because it's also a small white dog. Either way, great with names. Really good with names, and I get that from my father. That said, my mom, she always tells me, she says, "You're lucky I named you," and yeah, she's probably right. So okay, so we're gonna call this Service, and then we have the choice of what kind of packaging, jar or war. I'm gonna leave it with jar. Then, my friends, we have the choice of what version we want to use. I'm gonna use Java 21. Friends, you might have noticed there is no Java 8 here anymore, and certainly nothing earlier than that, because in order to use Spring Boot 3.x and later, you need to use Java 17 or later. But friends, if you're going to make the jump to 17, and I'm assuming you already have, really, you're woefully behind if you're still stuck on Java 17. This is ancient, creakingly old technology at this point, decrepit, way past irrelevant, no longer valuable. But if you're still, for whatever reason, marooned in the desert of Java 8 and you're making the jump to Java 21, or rather to Java 17, might I just suggest you skip that and go straight to Java 21. Java 21 is far better. It's technically superior in every way. It's faster, more secure, more robust, more syntax rich, more operations friendly, more platform friendly, etc. It's technically superior in every way. It's also morally superior, my friends. You won't like the look of sadness and despair and chagrin in your children's eyes when they find out that you're still using Java 8 in production. Don't do this. Be the change you want to see in the world. Do the right thing. Use Java 21. And actually, Java 21, friends, is just, it's not just syntax. That's what we're going to talk about. There's whole new paradigms today, okay? So there's that. I'm going to bring in the GraalVM native image support. I'll bring in the web support. I'm going to bring in the Postgres support. I'm going to bring in the Docker Compose support. I'm going to bring in the Spring Data JDBC support. I'm going to bring in the dev tools for live reload support. I'm going to bring in, I think I'm okay with that, actually. I think I'm satisfied with this selection. So Java 21, Spring Boot 3.2.1, but I'll have to do that manually. And everything else is as it should be. So let's go ahead and hit generate and open this up in the IDE here. Here we go. I've got a little program called unzip and open, UAO. It's an alias. And all it does is it runs unzip on the zip file and then runs idea space pom.xml or build.gradle. I just realized that I generated the Gradle one. I haven't tried that out with Java 21 of late, so I'll use Maven for now. Here we go. Oh, come on. It's thinking. Okay, so remember what I said. First things first, just for our purposes, today, here and now, we're going to go right back to 3.2.1. I'm going to save myself some anguish later. Just there's one little bug. It's getting fixed. Don't worry, it'll be fine. It doesn't stop most of what you're doing, but you'll see later. There's one little issue with GraalVM native images. Okay. All right. So we've got this new application, service application.java. Here's my code. I want to start making. I want to live that git clone run lifestyle. I want to be able to take the code and start making changes to it immediately. And so to that end, I selected the Docker Compose support on start.spring.io, and the initializer was nice enough to generate a Docker Compose YAML file, which I can then run here, right? Let me see. Do I want to update that? Sure. What could go wrong? Good. So then Docker PS. Okay. There's that. Docker RMF. Get rid of that. Get rid of that. Okay. Docker PS. There you go. So now I'm going to say Docker Compose up. I'm just going to let that run in the background. And if I had let Spring Boot, it'll run it for me, actually, right? So if I hit Control C, and then I leave this selection here, it'll actually start the application up for me. Okay, so there we go. Let's let that do its thing. And you can see it takes an achingly long time. The reason it takes an achingly long time is for the aforementioned reason, which is that it's downloading the Docker image and actually starting it up. And it's pretty quick to start Postgres up these days, but still, it ballooned my startup time, to such an extent that I can't abide it, right? And so what I want to do is I want to make changes and go as quick as possible, but that's too slow. And so what you can do, there's a couple things you can do. One is you can tell Spring Boot to leave it alone, right? I can just say start it only. So if it's not running, start it. Otherwise, just let it run. And that's part one. And the other thing I can do is I can use dev tools. Dev tools are a great way to make changes and recompile the code. Java is many things, but fast out of the gate, it is not. And so as a result, the core conceit of dev tools is, hey, I'm going to make a change to some code. I'll create a class file that'll get compiled and loaded into the file system. I'll then reload that class file into the class loader and then see those changes reflected in the running program without restarting the JVM, because I can just recreate the Spring application context to reflect that new class loader, and I don't need to restart the JVM. So that's actually a really good insight, right? So let's try it out. So let's make some changes to our code. First things first, I'm going to build an entity here to model our entity of type customer. I'm going to use records, right? Now, I love records. I just love records so much. These are such a nice feature, right? Such a nice feature, and I can just describe an entity. And the contract behind a record here, this is not a Java 21-ism, it's a Java 17 ism, but the contract behind them, the core conceit here is if I agree that the identity of my object is equal to the identity of the components of that object, that is to say the ID and the string, then I can do all sorts of things. I get some benefits from that. The language will create constructors, it'll create storage, it'll create getters and equals methods and hash code methods and toString methods all for me. Records are kind of like tuples in other languages, right? Java is a nominal language. That is to say, we like to name things. So when you use a record, what you're actually doing is creating a tuple that has a name, okay? And you can create records anywhere. You can create records inside of methods, right? While you're in the method. So if you wanted like a throwaway type just to have something to glom onto, create a record. It's easy, it's cheap, it's syntax free, it's easy, right? So now this is a nice feature already. You got a lot from that, but this is actually part of a whole suite of features, right, that come and culminate in Java 21. These are sealed types, records, pattern matching, and the smart switch expression. So let's see, let's just take a little digression together, my friends. We'll just take a little digression and look at how some of these features kind of work together. They collaborate. They again, there's that word again, synergized in Java 21 to support what Brian Getz, Java language architect, Brian Getz calls data-oriented programming. And the idea here behind data-oriented programming is that that Java has historically been very, very successful in the world of the monolith, right? Large applications with deep-seated hierarchies of types where the channel of dispatch, the mechanism of dispatch, the way you communicate change in the system is by inheritance, right? And in that world, with Java's strong type system and its good compiler and its privacy rules and so on, it's actually been very successful in large code bases, the large monolith style code bases. But now, increasingly, even if you're building a modular monolith, you're probably building something smaller than what you would have built, let's say, 15, 20 odd years ago. And these applications have a lot of moving parts for sure, but the way you communicate change these days increasingly is in terms of ad hoc messages being sent across the wire. Think Kafka or REST or something like that. Those messages are data, right? They're not deep-seated hierarchies. They're data structs. They're holding payloads that you have to work with. And so the way you communicate change now is in terms of these messages, not in terms of deep hierarchies of types. And so the language has to grow to support that, to be better at working with data. And that's what it's done. And there's these 4 different features that I mentioned: sealed types, records, pattern matching, and smart switch expressions, taken together support this new paradigm. So again, let's go back to our example. Let's say we're in a highly regulated industry, like, I don't know, finance or banking or something. And we've got an interface called loan. Well, loans are highly regulated instruments in most industries and economies that have them. And so we want to make sure that people can't just create their own implementation of it, right? So one thing I could do is I could create a sealed loan, okay? And I'm going to create a sealed interface loan, and I'm going to create 2 implementations. So unsecured loan, implements loan, and secured loan, okay? And I'm going to tell the language, I'm going to say, okay, look, I've got these 2 implementations. These are the only ones that I've got. Nobody else is allowed to implement this interface, right? Because again, I don't want somebody passing an anonymous inner class version of loan into a method that bypasses the security checks and the validation rules that we've got in our business logic to do some nefarious thing, right? Real money is on the line here. We want the compiler watching out for us as much as possible. So I'm using sealed types to ensure that I've only got 2 implementations, but the compiler is upset. It's saying, hey, look, you told me that this is going to be a sealed hierarchy, that there should be only 2 permitted subclasses, secured loan and unsecured loan, and yet you left these wide open. They're not sealed, they're not final, they're not anything. So either make them sealed and permit subclasses or make them final, which I've done. Okay, so now we've got this. Now let's suppose we wanted to have a method that, generate a message for a loan, right? Loan, that's good. So now I've got that. Now I want to generate a message for a particular loan. Well, how do I do this? Well, let's say message equals this, okay? If loan instance of secured loan, var sl secured loan, right? I can do that. And, maybe the secured loan is just the lowest rate possible, so there's no interest rate or whatever, or the interest rate is fixed, so it's not worth making it a parameter, okay? So I can say, okay, well, message equals good job, well done. Enjoy that, right? Nice message, very, very warming. Okay, good. Now, what if the loan is an instance of unsecured loan, right? Unsecured loan. And here I can do USL, unsecured loan, and I can say return, ouch, that, and we want to have an interest rate for the unsecured loan, right? So I could do the obvious thing. I could say, okay, private, final, float, interest. But in this case, it so happens that really this is just a carrier for data. So instead of defining a field and create a getter and a constructor and all that stuff, let's just make this a record, right? Which is also by default sealed, or final rather. So there's my interest field, and I can say, okay, USL.interest is going to hurt, right? Voila. And then I'll say return message, okay? So now I've got these two different branches where I'm testing the kind of loan, but there's some ugliness here. First of all, I don't need this particular one because I'm not using it, but I could. But you know, we can use pattern matching. This is a new feature in Java 17, and so I can actually tell Java to extract, to match, to apply this pattern to match, and then to extract a variable. In this case, secured loan, and we can say that secured loan within the context of this test is definitely castable. That is to say, it's guaranteed that I can cast in here. And so the compiler says, okay, fine, we'll just give you a name, and you can dereference things on that object via that name. Okay, great. Same thing down here, USL. It's definitely castable. So now I can just reference it here. It's downcast to the version that has the interest. But still, this isn't great because, you know, what if I don't do this? What if I comment that out? The compiler is not helping me catch any missed branches here, right? I don't have exhaustive checking. And so what I want is to make this a little bit more concise and also to be a little bit easier. So I could actually turn this into a switch statement, but that doesn't give me the exhaustive check. And also, it's not very concise. So what I want to do now is use the new smart switch expression, wherein the product of the switch statement, the output decision of the switch statement, is actually assignable to a value, or it's a value that can be assigned to a variable. So let's do that. We'll say switch loan, and within that I can do pattern matching again, right? So USL, and now instead of me, see, I didn't even do that correctly this time. I actually had one branch that did a return and others that assigned it to a variable. But now I don't have to worry about any of that. So if it's an unsecured loan, I'm going to downcast, and then I'm done, right? And then if it's a secured loan, I can just return this message, right? So this is actually both more concise and better, because now I'm assigning it to a variable. It's very clearly a string, but actually I can just inline that, right? So I'm taking the input value, and I'm doing these pattern matching. I'm extracting out a variable. I'm using them within the scope of the cast, and then they're assigned. The resulting string is assigned to the product of the switch, right? Okay, that's nice, but let's say, what happens if I don't cover a case? Look at that. Well, the compiler's saying, hey, you don't cover all possible input values. So you can get around this by either having a default branch, right, like that, which is, you know, don't do that. You're disabling some of the best features of the language. Or you can just do that. And so now the compiler is helping me make sure that I've covered all the very, very important cases here. And you can do that throughout the code base. So this is actually less code and the result is better. But we can still take it a step further. I only need the interest. That's the only component I want from that unsecured loan. But I'm actually getting a pointer to the root of the aggregate, the unsecured loan itself. Well, if I just want that, then I can just extract it out like this. Var interest. This is more pattern matching. And now, within the scope of that definitely castable block, that interest is now extracted, right? I get the interest hoisted out of the component. It's sort of lifted out of the component into context, into scope, and then I can use it within that string, right? How convenient, right? So now I'm getting pattern matching. I've got smart switch expressions. I've got, and by the way, you know, you don't really see it here, but also you have multi-line strings now, which is nice. So this is, you know, it's just a very different language. So even though I'm going to just use it for that, don't sleep on records. This is one of those things that just plays super nicely with data-oriented programming, things like Kafka, things like REST, which of course people do a lot of in a typical Spring application. Okay, so we've got this now. We've got our basic record. Let's create a repository. Customer repository. Extend list of CRUD repository, customer, integer. Okay, and we want to create a we want to have data in the database, right? So I'm going to tell Spring Boot to initialize it, to initialize itself, initialize the database by putting a schema.sql file here, create table, if not exists, customer, ID serial primary key, name varchar 255, not null. Come on. Go, good. And I'll have a, this goes in the root resources folder, okay? And I'll have another file here called data.sql. And I'm going to say delete from customer. I'll say insert into customer, name, values, Josh. Who else is on the Spring team? Of course, Glenn. Couldn't forget Glenn. We got Madura. We've got Olga. We've got Violetta, Yushin, Dr. Sire, Stefan. Okay, very good. So we got now 8 records. That's a nice round number. You can divide it by 2 and then 2 again. It's still 2. Easy to sleep at night. And finally, I want to tell Spring Boot to initialize itself with that. So I'll tell it to initialize the SQL database, not just the embedded ones like H2 and Derby and all that, but even the remote ones that are, I'm connecting to over a socket, albeit on the same host. So I'm going to tell it to initialize itself. Okay, all that done. I want to restart the application, and I want to see things working. Let's create a simple controller first, just so we have something to hit to make sure it's working. So customer repository, add that, add controller, add response body. Okay, now if I want to create a simple HTTP endpoint here, trivial HTTP endpoint, customers, collection of customers, turn this .repository find all. Very good. So there's our controller. I want to restart the application, but again, I don't want to wait for that whole Docker lifecycle thing to happen again. So what I'm going to do is I'm going to recompile. And on the Mac, in IntelliJ, you do Shift Command F9. If you're using Visual Studio Code, you just save it. That's all you got to do is just save the file. Eclipse, same thing. It'll trigger the dev tools. But for IntelliJ, for some reason, you have to, because there is no save mechanic in IntelliJ. There's no, one does not save, right? It's always being saved for you. It's always being synchronized, whatever. So I don't even know how you would save. I guess you could do save all, but again, I don't know what that exists. I don't know what that does. But the point is, if you want to force it to reinitialize, you do recompile. So Command Shift F9. So I'm going to do that here, okay? And when they do that, it again, it's just going to recompile the delta. So this time it started in 0.4 seconds, right? Far sight faster than the full 2.5 or whatever it was seconds that we saw initially. So now we go here, localhost, customers, et voila, it worked. Of course it worked. It was a demo. That was always going to work. And so I'm happy with that. Let's go ahead and now, what can we do next? What can we do to improve it? We're moving quickly. We got that Git clone run lifestyle. We got dev tools allowing us to make changes quickly. We've got the really concise syntax that Java offers, allowing us to get a hold that access repository and an entity in 4 lines of code. Take that, JavaScript, right? We're doing good. But what I want to do now is, let's take this a little bit further. All of the stuff is more concise and more productive and more efficient, but it's basically the same thing as you could have done years ago, 10 years ago, 15 years ago, etc. And by the by, I say all that cognizant of where we are in the moment right now, right? If you go to spring1.io and then go to history of Spring, last year we celebrated 20 years since the first early access builds of Spring Framework, of something that looked like Spring Framework 1.0, right? And so, that was in early 2003, and then last year was 2023, right? And this year, 2024, we celebrate 20 years since the first 1.0 release of Spring Framework, which of course began the revolution that is the Spring ecosystem. And so you can see there's this little video game, Spring 1.0 is released, right? We got all that. Go through here, go down, go up around, go up into the clouds, right? Spring Cloud 1.0, Spring Cloud Tasks, Spring Cloud Stream, Spring Cloud Data Flow. Glenn works on a lot of this stuff. Now we're in the water, right? Kubernetes, Spring Cloud Data Flow for Kubernetes. We've got Spring Cloud Skipper. We've got Spring Cloud Gateway for Kubernetes. We got Spring, and then 2022, that's a couple years ago now. I can't believe it. We have Spring Boot 3.0 and so on. So when I say that you could have done this stuff before, I mean, it looked something like this. We've had ORMs and web frameworks and all that for 20 odd years now, at least. But basically, it's gotten more concise, more efficient. That said, there are some new paradigms, right? There's always new things on the horizon. And one of the things about which I'm sure you've no doubt heard of late is AI. And apparently the search for I was going so well that we feel like we can venture off into AI. And I don't know if I'm on board, but whatever. And AI, the whole thing to remember here, friends, is that it's just another data store. It's just another thing with which you're going to connect your application, right? Or to which you're going to connect your application. And so in the same way that most people don't need to write their own SQL databases, we don't need to worry about writing our own LLMs, right? We just want to consume them. And to that end, there's a whole ecosystem, there's a whole discipline around how do I write code to talk to these LLMs, these AIs, and extract data out from them. Consider that a lot of these AIs have context windows. Those windows are the number of tokens that you can send into the request to extract out a response. And to inform the response. Remember, these AIs are trained on training data, which is then frozen. And in order for them to know about new things, they have to be retrained. So it's not useful to try to do that. Instead, what you do is you do context stuffing. You send a request, but then phrase the request or write the request in such a way as to give the AI information about the data on which you're operating. So if a customer logs into their bank account and they want to talk to an IVR, an automated AI-driven IVR, and ask it questions about their bank account, then you, behind the scenes, would craft the request in such a way as to say, hey, here is Josh, and he has 2 coffee beans in his bank account and some belly button lint. Please, when he asks about it, respond as such, right? And so that's context stuffing. And so the question then is, okay, well, if I know that's the name of the game, then there's a whole pipeline around finding data and putting it in a place where I can get to it in a fairly free-form textual kind of way. That's a vector store. So you need integrations with vector stores. There's a number of them out there. And then there's all the work around extraction and summarization, and with things like Apache Tika and so on, to take large chunks of data, synthesize it in smaller amounts so that it fits within the context window that you want to then use to send a request to an LLM. And that whole pipeline of getting data prepared and compressed and ready for context stuffing so that you can then issue a request that's useful for your user, that's called RAG, or Retrieval Augmented Generation. And it's a whole thing, right? It's a whole pipeline that you have to start thinking about. And to that end, we have a project called Spring AI that provides integrations with tools to support retrieval augmented generation, and with data stores like vector stores, and with, of course, any number of these different LLMs, including Google's Vertex, including OpenAI, including Azure, including Hugging Face and Ollama, and just countless scores of others as well. So let's go ahead and pull that in, and we're going to use it. Okay. So it's an experiment. It's not an experiment. It's a new project. It's not yet GA, but it's really good. So here we go. Copy that. I'm going to go back to my build. Here we are, and I'm pasting this in. So the dependency is Spring AI, OpenAI, Spring Boot Starter. I'm going to add this repository, the snapshot repository. So repositories, et voila. Okay. Command-Shift-I. Good stuff. So now it's on the class path. And I've already, friends, in order for this to work, you need to provide a OpenAI API key. Okay. Well, I need you to just believe me when I say I've already done that. I've done this. I've taken that property name and exported it as an environment variable. And then that's in the context. That's in my shell. So forgive me for not leaking my OpenAI credential to you. Just trust me, it's been done already. Okay. So now I've got this, and I want to build a new endpoint here. Let's say @controller @response_body class singularity controller from Isaac Asimov, right? I'm going to inject the AI client. Okay, here we go, and I'm going to ask it to tell us a story. So let's say story map string. Here we are. Okay, story time. All right, good stuff. So map.of story. And in order to get the response, I need to have a prompt, right? So this is where those multi-line strings about which I was speaking earlier really come in handy. And so I'll say singularity dot generate, passing in the prompt. And the response is this, all right? Good. There's the response. It's this thing right here. It's a string response. I've got the prompt. It's a multi-line string, and I can say, I can ask it whatever I want. So it's very important here, friends, to be polite, because they remember that kind of stuff, and when they take over, it's to your benefit to have been polite. So I say, dear Singularity, please write a story about the lovely Java community its many Spring users, and the amazing open source software therein. And would you please write it in the style of famed children's author Dr. Seuss. Now, Dr. Seuss is yet another one of my favorite doctors, along with Doctor Who, Seuss, Strange, Subramaniam, Sire, DeVolder, and Pollock. Okay, and by the way, Dr. Pollock is the lead of Spring AI. So if you like that and you like what you see, then you can talk to me. But if you don't like that, you should definitely talk to him. He's the only one that can do anything about that. Okay, so would you please write in the style of famed children's author Dr. Seuss? Thank you cordially, Josh. Okay, very important. Good. So now I've got the prompt. I'm going to go ahead and restart. I have to do a full restart because this is a class path change. It's no longer just a dependency change there. So I'll go back to my build here. Let's just clear all that. Where's Maven? Maven, come here. Okay. And I'm going to restart, reload, Command-Shift-I, the entire build, re-import it and all that kind of stuff. And then I'm going to restart the application proper. I'm not doing DevTools here. I'm doing a full hard reload. Ah, that's good coffee. All right, so started. It's up and running. Everything's there, hopefully. So now if we go to story, /story, localhost story, okay. It's taking its time. It's a good thing we have this thing to play with. Okay, there we go. So it took a long time, but we got a result. Oh, the lovely Java community, so grand and so bright, with its Spring users shining like stars in the night. They gather together in forums and chats, sharing their knowledge like friendly old cats. I've never been called a friendly old cat, but I quite like that, actually. In this world of coding, they all have a place with the amazing open source software that they embrace. They use Spring Framework with its magic and charm, creating applications that keep us all warm. I don't know what that means. I think the AI is thinking of Scala. When you do the compilation, the CPU fan starts burning. Spring Framework, so powerful and strong. It helps Java developers all day long. With its inversion of control and dependency injection, it brings simplicity and joy with no need for reflection. I love this. I love it. Thank you, AI. This is great. So yeah. Okay, we've got the freaking singularity writing poetry for us now. It's an amazing time to be alive. But consider what just happened. I made that request and awkwardly leaked my Google Drive recent list. And you can see I've got deliberations for my impending 40th birthday party. And that was just really, and then we had time to go to the history of Spring. And we almost got halfway through the entire 20-year span in the time it took for that AI to generate a response. Now, it did a good job, okay? Nobody's arguing that it didn't, but it did take a fair bit of time. Certainly a lot less time than if I had to write that same poem myself, okay? Again, I'm not complaining, but think about what happened, right? It took a long time, long enough time that we noticed it. And what does that mean? Well, from the perspective of the service that we're building, it means that we've got a thread that's attached to that request, right? There's a web server, Tomcat, underneath Spring Boot that listens for requests on port 80. There's a server socket. When the server socket gets a knock, basically, when a client knocks on that port, the server socket accepts the incoming port and then dispatches that server socket and that socket to a new thread. And then there's the whole servlet machinery apparatus that then gets involved. And then ultimately that request gets sent to Spring MVC. And Spring MVC then invokes my git mapping method. And me here in this code, I've got this call that's using the abstraction provided by Spring AI that is in turn making a call to the OpenAI API, right? And that's using presumably input stream and output stream. Well, that's where things get murky, right? We waited for that response. We said input stream.read and then nothing, right? And we're stuck. Just imagine that we're on the line of the code with input stream.read. We're making that request and we're asking for the next byte to arrive and nothing's coming for seconds, whole seconds. And so we're stuck on line, let's say 10, right? And in order to get to line 11, we have to wait for the whole response to be generated by the AI before we can then proceed. So we can say that we're blocking, right? Input stream.read is a blocking operation. What I mean by that is that on whatever thread of execution we happen to be running, we're stuck in that point until we can get that response that we want, which is not itself so egregious. It's just that up until recently, the way that Java modeled threads meant that sitting on a thread and blocking it was a really big opportunity loss because we couldn't handle any other requests. Because up until recently, the total number of threads that we could create usefully in a single JVM was fairly limited, right? You couldn't create millions of threads. They're very expensive. They take up a couple of megabytes of context, of bookkeeping associated with the operating system and all that. So it's very slow and painful to create threads. There are ways to get around this, right? You've probably perhaps seen me talk about reactive programming at some point in the last 7 odd years, right? I love reactive programming. It's a great paradigm to get around this situation. You basically write your code in such a way as to give the runtime an opportunity to yield the thread back to the thread pool while you're waiting for something. You're doing non-blocking I/O. But it's a different paradigm. You have to change the way you think about writing code. Instead of pulling data out of input streams, you have the input stream push the data to you when and only when it's ready. So you never spend any time on the thread waiting, just idle, because you don't have a chance to do that ever. As soon as you enter a wait state, the runtime automatically puts you in a holding pen waiting for the response. And then as soon as the bytes are there, then you get put back on a thread and allowed to continue. But it is a different paradigm. You have to change the way that you write your code. And so the common lament is, look, I get the benefits, but I'm just not able to make the to jump the mental gap here to get good with reactive programming and that sort of functional style of programming. Fair enough, okay? Fair enough. It's not for everybody. Point taken. So the question then is, can we have our scale cake and eat it too? Well, now with Java 21, we can. You see, now there's a new runtime, a virtual thread runtime that recognizes when we're doing something blocking and automatically rewrites the code at compilation so that when we do that blocking thing gets moved into a holding pen automatically, and then the flow of execution on that next line is only continued as a continuation, as a callback, essentially, when that blocking thing is done. So what qualifies as a blocking thing? Well, we talked about input stream.read, but there's also like thread.sleep, output stream.write. I mean, these are blocking operations. The runtime automatically knows when you're doing these things and moves the thread of execution off the thread. So in order to see this in action, let's take an example that I'm going to steal shamelessly from my friend, the amazing Jose Pomar. He's a professor in France on the Java developer advocacy team for Oracle. And this is his example that I'm stealing, I'm pillaging. He's brilliant, and I really like his example. So let's say threads, new array list, thread 4, and I'm going to create a bunch of threads here, okay? Not like a crazy amount, but 1,000, let's say. And I'm going to stuff them into this threads list, okay? So thread, and I'm going to create these threads using the traditional style, okay, of platform, unstarted, new, runnable, okay? Put that in there. There's my my unstarted threads like that. And for var t threads, t.start, and then I'm going to start each of the 1,000 threads, and then having started them all, I'm going to wait for all of them, and that's going to run these threads. These are not started by default. They're not running yet. Once they're started, what am I going to do? Well, I'm going to do something that does blocking, okay? I'm going to say thread.sleep, 1,000 milliseconds, add that try catch, and then I'm going to, if I'm in the first thread, I'll say first equals I equals 0, right? If I'm in the first thread, if first, then I want to capture the current thread's name. So names equals new concurrent skip list set of string. And yes, that's a lambda, very good. And so if it's the first, names.add thread.current thread.toString, okay? And so I'm just sleeping, let's say, let's not even do that much. We'll just do 100 milliseconds to keep it paced, okay? So I'm going to sleep 100 milliseconds no matter what thread I'm on. But if I'm on the very first of the 1,000, so the same thread, I'm going to keep track of it. Then I'm going to note the current thread name. And I'm going to do that again. That's the second time. and again the third time, and again the fourth time. Okay, so now I've added. I'm using a set, and what's one function of a set is that you can put multiple things in, but if they're the same identity, then you only have one in the set. That it gets deduped in effect. Okay, so I'm on the same thread, right? I'm testing to make sure I'm on the same thread. I'm doing the blocking thing, then testing if I'm on the same thread, then adding the name. Okay, so now once I've done that, I can now go over here and I'm going to print out all the contents of the name set. Okay, so now Command Shift F9. Okay, here we go, and you can see, as predicted, as you surmise, given the physics of Java for the last 27 odd plus years, we started on a thread and we continued to exist on that same thread, and nothing is surprising about that, right? There's only one entry in that set. It's thread number 138, thread 35, etc. Okay, great, fantastic. Now, remember, this is using platform threads. This is what we used to use. This is the default. If you just create a new thread by default, you're getting this. But now there's a new thing, virtual threads. So all I've done is I've changed this constructor. I'm going to restart this application. Okay. Look at that. So virtual thread 1169, it's the same virtual thread. It's the logical virtual thread 1169, 1169, 1169. But you can see the actual thread, the runtime thread, the operating system thread, the carrier thread has changed out from underneath us 4 different times. But you didn't see me change the code. I didn't change the code. The code was written such that the runtime understood that, hey, on line 41, we're about to do a blocking thing. So we're going to go into a holding pen for 100 milliseconds. And as soon as that 100 milliseconds is done, the compiler let us continue executing down, down, down until we got to the next blocking thing. And then it waited, put us in a holding pen. And while we're in that holding pen, guess what happens? That thread is free. Something else in the system can use it to handle a request. So what does that mean for us? Well, probably not a lot, right? Most of the time, we're not writing low-level threaded code. Do you know Tony Hoare, this guy, right? He's the one who postulated that null is the $1 billion mistake, when of course that was wrong. It's actually PHP. PHP is the $1 billion mistake. And then also he is the one who in the 1970s said, and it's 70s, right? I mean to say that close to 50 years now, he said that threading, multi-threading in the code and style that I have here is not a good way to build scalable concurrent systems. It's a foot gun, right? It's a great way to hurt yourself with very little benefit. There are much more structured approaches to building concurrent systems. So certainly, I hope you're not doing this. And just remember, if you are, there's only one person who truly knows how to write multi-threaded Java code. Only one person, and it's not you. I don't know who it is, but it's not you. That's the important bit, right? There's only one, and so we have no business doing this. Most of us are going to work at a higher level. Certainly, we're not going to create our own threads. We'll probably use an executor service, right? If you're using Spring, you're accustomed to plugging in executor services. These are sometimes thread pools, but if you're using the new virtual task or virtual thread per task executor, this is not even a thread pool. It just creates a brand new thread every single time. You know why? Because they're cheap now. Virtual threads are cheap. You can create millions of them. So you write your code, you do this blocking thing. Remember, that call to OpenAI, that's a blocking thing, but it's automatically going to rewrite the code so that when we're on line 42, then we get to the blocking thing, we get moved to a pen, then the blocking thing finishes, we get put back on the thread to continue executing. So that whole time, we're not losing 800 milliseconds of precious activity on the thread. The runtime is able to automatically do that interleaving for us. This is a huge win, right? Because now we get the same kind of vaunted scalability, right? The ability to handle a good deal, many more requests at the same time without having to spin up new instances in our cloud infrastructure, for example. This is a huge deal and it's free. And if you're just doing multi-threaded Java code, you can just switch the constructor or you can use a different virtual thread pool. But even there's a number of different places in Java and in Spring where you need to provide a thread pool, an executor service. But if you're using Spring Boot 3.2, well, guess what? We'll do that for you. Just do that. And now it's done, right? So that Spring MVC call where I'm making a network call to the OpenAI API, who cares? Who cares if I sit there for a second wasting time? It's not actually keeping a thread right? It's not monopolizing that one thread to the detriment of the rest of the system's scalability. Now everybody else in the system can still use it while we're waiting for that thing to happen. And you didn't have to change anything. This is free money. Free money. You can probably scale down instances. Try it, obviously. You should instrument your own stuff, but this is win. You just upgrade to Java 21 and profit, right? You should tell your management when you do this, hey, I'm gonna save us some money and really increase our scalability, but I want to take part in the profit, dividends here, the savings. If we save X dollars, I want to get part of that. It's probably fine. You should do that, or don't. I don't know, whatever. I would. This is a good deal. Don't tell them it's Java 21 that's doing all the work, okay? Job security. Okay, so now we've got Java 21. We're doing good. We're talking to the freaking singularity. Now it's time to get this thing into production. And I think we're in a good place already, but there are some questions that come to mind. First of all, how do I containerize it? And there, friends, the answer is pretty straightforward. We can just use build packs. Build packs answer the question, how do I take an application and containerize it? And friends, remember, friends don't let friends write Docker files. Don't do it. By the time you've done it, you've already got a CVE. You've already got one. Just as soon as you commit it, there's probably 5 CVEs. Don't do it. The build packs are basically open source recipes for building containers for particular kinds of workloads, be it Spring Boot jars or Tomcat .wars or .NET EXEs or Ruby on Rails projects or Django Python projects or Turbo Gears or Flask or whatever, right? There's all sorts of stuff here. Node.js or GraalVM native images or whatever. So this is already a good answer. And I'm not going to spend time on it because it's an old trick. I just want to remind people it's there. Put that in your pipeline, and then you can Docker tag and Docker push that container to your container registry of choice. Okay, great. Next thing is I want to make this application as scalable and efficient as possible. And here, friends, it's worth remembering that Java is already super, super efficient. There's this great blog from 2018, before the COVID pandemic, called Which Programming Languages Use the Least Electricity? And this asks the question, it says, what are the normalized results for energy, time, and memory across different languages? And friends, the results are pretty interesting to me. You've got for energy here in particular, you've got C. We can see that C is the baseline. It is the most energy efficient for machines, okay? Very important, not for people. Definitely not for people, but for machines, it's very, very energy efficient. We got Rust, zero cost abstractions, doing quite well. Good on you, good job. We have C++. Disgusting. Moving on, we got Ada, nope, no thank you. And we've got Java. And Java, my friends, is 1.98. Let's call that 2. Let's just round up, simple math. 2.0, okay? So C, 1.0, Java, 2.0. We can therefore say Java is twice as inefficient or less efficient than C, okay? Or put another way, C is twice as efficient as Java. Good stuff. Good stuff. Moving down, got Swift. If you're using iOS and Mac and iPad and all that, or the new Vision Pro, which I confess I want. If you're using all that stuff, that's Swift, right? That's going to be this language right here. Okay, great. C#, good stuff. Look at that. You got Go, Away. You got JavaScript and TypeScript. I don't understand this extraordinary asymmetry. I thought TypeScript compiled into JavaScript. These numbers make no sense. Just don't use either of them if you can. I just avoid them both. Or if you're a TypeScript user and you're feeling bad about this, just know that you're in good company, because I would choose TypeScript too. JavaScript is an imaginary language. It's not even real. It doesn't know about numbers. I can't build websites that need numbers in them if you don't know about them, So moving on. Then we've got Hack and PHP, and of course these are disgusting, and we're going to move on. You got Erlang and Lua, all right, good. And then we got JRuby and Ruby, and look at that. JRuby is Ruby implemented in Java, and Ruby is Ruby implemented in C. And JRuby, just by dint of having been built on the JVM, is almost a third more energy efficient than the equivalent C code. The JVM is boss sauce software. You get incredible benefits by building on it. Never let anyone tear it asunder. It's an amazing piece of kit, and we are benefiting from that. And then we get Python. And friends, this makes me sad because I've been using Python since the 90s. Bill Clinton was president when I started learning Python. And so I'm a big fan, huge fan. And yet this is not good. We can't, this isn't good, especially now with the rise of AI and all that. This is a really problematic thing. It's 70, let's just round up again, okay? 76. What that means is if you wrote a program in Java and that program created used a little bit of energy, and then that energy resulted in carbon being released into the atmosphere, which then raised the temperature such that one tree died. Well, if you wrote that same program in Python, well, what is that? Well, that's 76 divided by 2. I'm not very good at math, but you know who is good at math? Freaking Python. So let's ask it. It's 38. What that means is that equivalent program in Python would kill 38 trees. That's a forest. That's worse than Bitcoin. We have to have a conversation about this, right? That's not good for anybody. Anyway, I forgot what we're talking about. Oh, right, Java. Java's amazing. It is really good, but can we make it even better, right? And you probably have seen the results from the 1BRC. Have you been following Gunnar Morling's 1BRC challenge recently? Is that it? 1BRC? Yeah, this one, the 1 billion row challenge, launched by Gunnar Morling. Whoop, nope. This one. 1 billion row challenge, right? The original blog post, here's the solutions from Gunnar Morling. And no, it's not from, it's a challenge that wherein he asked people to submit a program in Java to read 1 billion rows of weather station telemetry, basically like CVS data, just a few. It's not too wide, but there's a billion rows. And the question is, using stock standard Java, you can't bring in a framework and all that, how fast can you get it? Well, there have been some remarkable responses here. Like at this point, the leading entry, and there's hundreds of them at this point, right? There's the leading entry in Java can read and process and do statistics on those billion rows in under 2 seconds. That's from you hit the command line, hit enter, the program starts, reads all the data, and produces the response all in less than 2 seconds on a billion rows, right? That's gigabytes of data here. I mean, it's phenomenal what you can do in Java. Let nobody tell you otherwise. It's an amazing thing. And what can we, so that to that end, what can we do to make it even faster? Well, I want to take advantage of GraalVM native images. GraalVM native images are an amazing thing. GraalVM.org. GraalVM is an open JDK distribution with some extra niceties. Obviously, it has the just-in-time compiler, which retroactively compiles frequently accessed code paths on the JVM and turns it into native operating system and architecture-specific code. This is a great thing. But we also have some code that is, that we know needs to be fast. Why do we have to wait for it to get run a number of times before we can do that? Well, now we don't have to. We have an AOT compiler, an ahead of time native image compiler, and we can use that to turn our code into GraalVM native images, right? Architecture and operating system specific native images. There's only 2 problems with this. First, you have to provide JSON files, right? And those JSON files, well, there's a lot of them. You have to provide configuration JSON files that specify things like when you're doing reflection, when you are using class loader resources like class path files, when you're doing serialization, when you're doing JNI, when you're doing JDK proxies, all these dynamic things that are sort of escape hatches that get around or circumvent the runtime's ability to see and then foreclose upon the possibility of new types entering the type system. They sidestep that ability, and therefore they are a problem. So you need to tell GraalVM about these things so that it can seal the type hierarchy, so to speak, and know exactly what you've done and when you're doing it and why you need to do it. So this is one thing you have to do, is you have to write these JSON configuration files. The other thing is, I don't like saying JSON. It just sounds stupid. It doesn't, I have a hard time saying it to other adults, actually. It just sounds like a goofy thing to talk about. And we talk about Java. I mean, there's some goofy names in our ecosystem, but JSON, I'm done with it. So I speak French, and in French you would say a JSON, which sounds so much cooler. It sounds way cooler. And also I was in Taiwan recently, and there they have a language called Hokkien, right? And in that language, you've got Jingsong, which means happiness, right? So pick your team. Either one's better than this, okay? I'm all about, I'm team Jisong, but it doesn't matter. Let's just move on past JSON and move to Jisong or Jingsong, okay? Now, that said, I don't want to write that configuration. I don't have enough time to write that configuration. I barely have enough time to finish this talk. Thankfully, Spring Boot 3 and later ship with an AOT engine. So we can use it to generate the configuration for us. Let's do that here, okay? I'm going to go here. I'll say Maven skip tests p native compile. And I'm skipping test because I didn't write any. So we're gonna let this run. And this is the only problem with native images. It does take a while. It takes long enough, in fact, that I get bored. Frankly, I get bored. I sit there sometimes and I'm just waiting for it to finish. And now I understand. Unfortunately, I understand this amazing XKCD cartoon from years ago that asked the question, compiling. What is the #1 programmer excuse for legitimately slacking off? My code is compiling, and the boss says, "Hey, get back to work." Two swashbuckling programmers say, "Okay, compiling." Oh, okay, carry on. Right? I get this now. I didn't think I'd ever get it. I thought this is a C++ joke, but now we are those people. And yeah, that's an unfortunate thing. 2024 is a weird year, right? So I get that now, and I get bored. I start humming. I start looking at the wall and just humming and playing music, right? So eventually I just said, okay, well, I wish everybody could hear music when they are waiting for the compilation. So I went to Oracle and I said, Oracle, buddy, please play elevator music during the native image compilation process. I said, I already hear elevator music in my head while I do these sometimes long-running compilations. I just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. And I got a great response, this one from Andrew Din over at Red Hat, saying, can you make it this elevator music? I'm not going to click on the link, but it's from the James Bond GoldenEye soundtrack for the video game, for the movie from the 1990s on Nintendo 64. Good choice. Somebody else adds, I would add that using beeps in general, not only for native image, really helped me reduce development time. Good point. My microwave can make a ding sound. Why can't my code? And then I got this great response from Dr. Niephaus, another one of my favorite doctors and a researcher on the GraalVM team, who says, thanks for your feature request, Josh. The problem with playing music during the compilation is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Anyway, he continues, I have prototyped a -- Josh Long mode. Let's see what that looks like. So you would go to the command line, do native image, just like I did, albeit via Maven, do -- long mode. You'd hear music. That's the whole point. Then it would say music brought to you by Josh Long. And then you want something to look at. So then it would just show you that, right? And I'm sure that's going to get merged any day now. Okay. Yes. So there's our build. So we'll go here. Service. It's going to fail because, of course, we're already running the Java process. Close that. Fails again because I don't have the database. Remember, I'm using Docker Compose. So I'm going to go to my talk directory. Okay. Okay, and now I'm going to run this script, but in order for it to run, I need to launch the Docker image, right? So Docker PS, Docker RMF, this one, Docker F, and then this one right here. Okay, now say Docker Compose up. There's that, okay? And that was just the okay, that was just this file right here. It starts the Postgres for me, and then I want to do run. I want to run that little shell script, right? It's going to run the native image in the target directory. So run. There you go. 0.1 seconds. Has the virtual threads. It has the singularity. It has all that other stuff, and it starts up in no time at all. Much more impressively, for me at least, since I'm not doing Lambda or something like that here. I'm going to look at the resident set size, which is measured in kilobytes. So you divide by 1,000, 116 megs of RAM. My friends, today we built an application. We took advantage of the amazing Java language and Java runtime and the advancements that are incumbent in that. We've looked at all the some of the amazing new features here in the Spring ecosystem that leverage those amazing features and that really work well, like Spring AI and its slight delays. It's a natural fit for Lambda for virtual threads. I hope I've persuaded you that there's never been a better time to be a Java and Spring developer. Thank you so much for your time. And as always, if you have questions, comments, feedback, you can find me on email there and on X there. Thank you so much, everybody. Have a great day.
Thank you, Josh, for the great presentation. I do have to make an admission when you were talking about your song, right? I asked Sebastian if he could maybe do dub over my presentation if I do them because he has this wonderful accent. So I was wondering if he would do my voiceovers for my presentations in the future. He said no, but I was hoping that he would. Okay, folks, for about 2 or 3 minutes, do you have any questions for Josh that you would like to ask? I saw a couple in here. Josh, do you want me to show this one to you and you have to take a peek?
Yeah, I can't see them, so just read them off to me if you like.
Here we go. How about that one?
Oh,
so is there significance? Yep.
It's because I'm not using actual REST, right? Every time, like, if you want REST, you need to do what Dr. Leonard Richardson talks about in his REST hierarchy. You know, the Richardson maturity matrix of hierarchy, you know, at the top level there is hypermedia, which I'm not doing. So I refuse to call it REST controller because then all the Restafarians come out of the woodworks and will actually me, and I'm not interested in that. So yeah, it's just an HTTP endpoint. It's not REST.
And toward the beginning, we talked about the bug of 322. Why we're doing it today, and that's just that native compilation, correct?
The native compilation with Spring Data JDBC, or maybe it's just Spring Data, but the native compilation with that is there's a slight issue. That thing I did earlier today, just a few minutes ago, wouldn't have worked. It would have stopped. So just wait until 3.3 if you're doing native images. Otherwise, you're probably fine.
Now, I'm going to go ahead and flatter you real quick because I think Daniel Adams had the best comment on you. So there you go.
He's thinking of somebody else.
Any other? Oh, sorry, I didn't say it's in big. Okay, not sure what that question was referenced to. Okay, well, oh yeah, the native compilation bug, correct. Well, folks, any other questions or? Well, Josh, thank you so much for your presentation. Folks, I hope you enjoyed the conference. Please continue. We still have a couple more presentations, I think, for today, and I want y'all to have a wonderful day. Folks, take care.
Bye. Thanks, everybody. Appreciate you.
And we are